Hi Ian, this is Sound the Loop, and this is the program that I wrote, and this is the rubric for the lab. And as you can see, I did the extra credit, and I so let's start with the intro to the program. So after you start the program, it's gonna say what the program will do, and then it's gonna say it'll calculate the area and the volume of cube, sphere, and tetrahedron. If after you input the common dimension being the side length, common length of cube, and for sphere it will be its diameter, and for tetrahedron it's going to be one of its sides. So after it's going to say what the program does, it's going to tell you to input the common length for the three object, and after you did that, it's gonna give you all the constant for the that the program is gonna use for the calculations: pi, square root of 2, square root of 3, and so the variable of pi, square root of 2 are all in capital as so the and after that, it's gonna show you what the answer for the area and the volume is gonna be. And for area of cube, so area, I use these formulas. So area of cube, it's gonna be 6L squared, L being the common length of cube, and area of sphere, it's 4 pi r squared, and r, I wrote it as L divided by 2. L is the diameter of the sphere, and r is the radius. So r is diameter divided by 2, so which is L divided by 2. And area of tetrahedron I calculated using square root of 3 L squared. Square root of 3 is one of the constant that I mentioned before, and instead of using the formula, I just put in the variable name, and it's gonna give me all the areas. And then for the volume, I use the volume of the cube, it's L cube, and then for volume of sphere, it's 4 by 3 pi r cube, and pi, same constant, pi. And then for volume of tetrahedron, I used L cube divided by 6 times square root of 2. Square root of 2, same thing, I used the variable name instead of the formula, and it's gonna give you all the volume values of the volume. And then after calculates the area and the volume, it's gonna ask the user what the common volume for the three object is, and then based on that, it's gonna calculate all the common length for those object. And then so 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 to find the common length, I just solve for x from the formula from volume, and then x being the common length of the object, and then after you solve it, you get a formula, and then I input the formula in the program, and then it's gonna give you all the length and diameters. And then after it shows you all the common length based on the common volume, it's gonna ask you for the common area, and it's the same thing as the common area, common volume. I just solved the for x from the area formula, and then you get the formula for the common length, and I input those in there, and then I'll tell you all the common length is. And so after that, it's gonna say the program is terminating, and so let's test out the program. So first, as you can see, it's saying what the program does, and then it'll show what the common length you're calculating for, what the common length is, and then you put in. So let's compare it with the sample that you provided. So see, it says, so let's say 1, it'll give you the area. As you can see, it's the same thing. The volume and the area are the same thing. And then, so for common volume 8, and then see, it's the same thing. So as you see, the program works after this. Now it's gonna ask you for the common area, and then common area. So let's see, common area, let's go for 120, and then site length of tetrahedron, as you can see, it's 8.321. It works. And then cube, site length 120, so it works for cube. Now time for sphere. So radius, what we have is diameter, so we have to divide it by 2. So divided by 2 equals this. So we just copied that radius and we put in it, and it's gonna say 120. So as you can see, the formula works for area, volume, and all the things it's supposed to do. So now I'm going to show you what the extra credit is, what I did for the extra credit. So as you can see, the program is gonna ask the user what the angle in degrees are, and then convert it to radian, and then calculate the sine, cosine, and tangent based on that radian angle using the formula. And then it's going to compare it with the built-in trig functions. So the first thing it's going to say is, after you start the program, it's going to say what the program does. It's going to say it's going to calculate the tangent, sine, cosine using the formula, and compare it with the values from the built-in trig functions. And the formula is, it's gonna say the formula is, it's gonna be pretty approximate, as long as the radian angle is pretty close to 0. So that's why I'm gonna use a small angle. So for example, let's say 15 degrees. So 15 degree, it's gonna give you all the, so as you can see, the answer are pretty close, and it's going to show you the radian angle too. And as you can see, the sine is pretty big compared to the cosine and tangent, but the overall it's almost accurate. So let's test it out for a big number. As it says, if it's big number, it's not gonna be that much accurate. So let's say 120, and you can see that the angle in radian is 2.09, which is not close to 0. And as you can see, the difference in number are pretty big. So as you can see, the higher the angle is, so the less accurate it gets. So the formula is only good for small angle. And so I think that's all it. So thank you.